All right, so today what we're going to talk about is we're going to talk about the base angle theorem. So the base angle theorem is it's on a isosceles triangle. So if I draw an isosceles triangle, if these two sides are congruent, right? So I have an isosceles triangle of A, B, C, okay? If AB is congruent to AC, and let's label this too. This is an isosceles triangle. Now remember, an isosceles triangle, it has two congruent sides. And we should probably talk about and label some things too. So this right here is called a leg, and this right here is called the leg of an isosceles triangle. And this is called, this right here is called the base. So just think of an isosceles triangle standing up on a base and then the two legs. Think of it like a tent. So now back to this theorem. If AB is congruent to AC, then angle BC is angle B is congruent to C. All right? And we call those the base angles. Okay? So then that means that angle B is congruent to angle C, and those are called the base angles. Now there's a corollary to this. Actually, it's not a corollary, it's the converse. So converse means that we can go in the opposite direction, sort of. The converse of the base angle theorem if I have an isosceles triangle, well, I don't even know if it's an isosceles triangle, but if I have a triangle A, B, C, and I say if angle B is congruent to angle C, then what do I write? What is the converse of the original base angle theorem? If I know that angle B is congruent to angle C, then what can I say? Well, then I can say line segment AB is congruent to line segment AC. Okay? So this base angle theorem and its converse is useful to us if we see an isosceles triangle. Then we can do a proof of that. Okay? Does that, anybody have any questions so far?